Hello and welcome to the video notes for lesson 9.3 Composite Figures. After this lesson, you should be able to use the area addition postulate to find the areas of composite figures and use composite figures to estimate areas of irregular shapes. The one vocab term we have in this lesson is a composite figure. We're going to look at what that is in just a moment. First, if you haven't done the warm-up, go ahead and take some time to do that now. Find the areas of those figures just to review how to find the areas of different shapes. If you need to look those formulas up, they're on the back page from your notes. And go ahead and find your answer. Don't forget units of measure, and we'll check our answers in just a moment. Okay, we should get these results. For a rectangle with a base 14 and height of 5, that's 70 square centimeter area. For a triangle with a base of 6 and a height of 18, that's 54 square inches. And for a trapezoid with base 1, 7, base 2, 11, and height 3, that should be 27 square feet. Okay, let's begin and let's take a look at what a composite figure is. A composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. To find the area of a composite figure, we're going to find the areas of the simple shapes and then use the area addition postulate. Remember, the area addition postulate states the sum of the individual areas within a figure is equal to the area of the entire figure. So in this process, we're going to take a look at the composite figure given, figure out what shapes have been put together, and combine those areas either through addition or subtraction and get our total area. All right, let's take a look at example 1a first. We're going to find the area of the shaded region. So to the nearest tenth is where we should round. Let's take a look at the figures that have been combined. It appears as if they've taken a half circle and set it on top of a trapezoid. So the areas we're going to combine are the area of that half circle, okay, which that's just the area of a circle divided by 2. And then we're going to add to that the area of a trapezoid. Okay, so we have to find those two different things. We'll add them together. The area of a half circle is pi r squared and divided by 2. The area of a trapezoid, remember, is base 1 plus base 2 times the height all over 2. So here's what we can do. We can find each one of these separately and then add them together. Let's look at the things we need to know. The radius of your half circle is going to be half of this 20 millimeter diameter, so the radius is 10. So we have pi times 10 squared over 2. Let's go ahead and simplify that. 10 squared is 100. 100 divided by 2 is 50 pi. I'm going to add to that this area. Base 1 of your trapezoid could be this 20 millimeter diameter of your half circle. Base 2 is the bottom of the trapezoid, 32 millimeters. The height is 14. We divide all that by 2. When I take 20 plus 32 multiplied by 14 and divide by 2, that number is 364. So my total area of the shaded region is the sum of 50 pi plus 364, which is approximately 521.1 square millimeters. We are told to round to the nearest tenth. Sorry, you couldn't see that. 521.1 square millimeters. Let's go ahead and try 2b. In this shape, it's a little more difficult to see these if you look at all of these dotted lines, but what I want you to notice is that they do mark parallel lines here and here and here and here. That makes this shape a parallelogram. Well, this is very simple now. It's just a parallelogram combined with a triangle. So we find those two areas and add them together. We're going to take the area of our parallelogram. We're going to add that to the area of our triangle. So those are the two things you should find. Remember, the area of a parallelogram is base times height. Area of a triangle is 1/2 the base of the triangle times the height of the triangle. So I'm going to leave you to look at these two figures and find their respective areas. And when you're ready, continue watching the video. If you need more time, go ahead and pause the video. Okay, so if we look here, the area of our parallelogram, the base of your parallelogram is 8, the height is 5. 8 times 5 is 40. area of your triangle is 1/2 a base of 10 times a height of 5. 1/2 10 times 5 is 25. So if I add these two areas together, we get a total area of 65 square feet. And that's as simple as that. When we have composite figures, we could add the total areas to get a total. However, if you look at the next example, these are some examples where we will have to subtract to get a total. So we're going to do a couple of these together. We're actually going to save part B to do in class, so hold off on that one, but we're going to do A and C. So if we look at part A, here's what we have. We have a triangle, but then we are taking out this half circle. We're not adding a half circle to the triangle area, we're removing that. Think of actually cutting this out. We would cut out that half circle. So the only area we are concerned with is everything but that half circle. Well, that means we need to subtract some areas. So here's how we should do that. For part A, we're going to take the area of our triangle, and we're going to subtract the area of the half circle. So let's go ahead and find those separately. Remember, area of a triangle is 1/2 base of the triangle times the height of the triangle. And the area of our half circle is pi r squared, and we're just going to cut that in half, divide by 2. Look at the base and the height of your triangle. It does not have to be the bottom and a perpendicular segment to that, because that'd be a little bit difficult to find. What we have is these two legs of a right triangle. Remember, the base and height are perpendicular, so we can use these legs as the base and the height, or the base and the height, you pick. The circle has a diameter of 9 feet, so the radius is half of that, 4.5. So the formula should look like this. For our triangle, we're going to do half of the base. If I call my base 26, then the height is 18. And for our half circle, it's pi times a radius of 4.5 squared, but then we take that in half because it's a semicircle. Why don't you go ahead and simplify these, do all calculations here and as many calculations here before multiplying by pi, and then find your results. If you need more time, pause the video. Otherwise, this is what we should have. When we do half of 26 times 18, that number is 234. When I do 4.5 squared over 2 pi, that simplifies to 10.125 pi before multiplying by pi. If you got a different number, you probably already multiplied by pi. I just want to save that until my final step. So when I subtract these, 234 minus this product, you really need to take this product first, 10.125 pi, and subtract that number from 234. You can use your answer key on your calculator, or you can do this in reverse order, make this a negative, and add it to positive 234. Either way, we should get about 202.2 square feet for a total area. Like I said, we're going to skip part B and do that one in class, but let's look at C. I want you to look at this and figure out how we could find the area of these shaded parts outside of this box. The shaded parts of the circle outside of the box. What you should notice is that we have a circle with a quadrilateral inside. What quadrilateral is that? You should notice that all four sides are congruent. It looks like it could be a square, but by the very least, we know that this quadrilateral is a rhombus, and that's what I want to think of it as. So the area of these shaded parts is actually the area of a full circle minus the area of a rhombus. Okay? And the main reason I want to call this a rhombus is because this diameter of your circle is also the diagonal of your rhombus. Well, if I take that same diameter and run it down this way, that's also a diagonal. So both diagonals of this rhombus are 6 inches. So what we need to do is find the area of a circle and take away the area of that rhombus. Your area formula for a circle is pi r squared. Area formula for a rhombus is diagonal 1 times diagonal 2 over 2. The diagonals of your rhombus are 6 inches apiece, so 6 times 6 over 2. The radius of your circle is half of that, so it's 3. Go ahead and plug those in and then check your answers when you're ready to go. If you need more time, pause the video. Otherwise, let's check our answers. Okay, when we simplify these, the radius of your circle is 3, so 3 squared is 9. So the area of your circle is 9 pi. And when we do diagonal 1 times diagonal 2, that's 6 times 6, or 36. Divide that by 2, and we get 18. So the area of your rhombus, or you can also call it a square because both the diagonals are congruent, we have 9 pi minus 18 for our total area. When we do 9 pi minus 18, that works out to be about 10.3 square inches. All right, we are going to skip example 3. We'll cover that in class. Don't cross it off. We will cover it in class. But I want us to go ahead and look at example 4 so we can look at the other type of problem you might see. One thing we can do is use composite figures to make estimations of areas of what we call irregular figures. This figure is irregular. It's not made up of straight connected lines that form polygons, but it has some areas where we can make assumptions or estimations as to that area based on what it is close to. You can see that I've split this up into 4 quadrants or 4 sections that I can find areas of. This is a triangle, this is a triangle, this is a rectangle, this is a trapezoid. I can find the areas of these 4 pieces to make my estimation as to what I think this total area is. Now it tells you the grid is 1 by 1. So let's look at what the things we have here. We've got a triangle, and it looks kind of weird, but if I call this my base, that's a base of 2. This is the height of 1. Okay, base is 2, height is 1. Okay. This rectangle is 2 by 1. This triangle has a base of 1, a height of 1. This trapezoid has one base of 1, one base of 2, and a height of 1. So we can find all those measurements. So let's take a look at what we get. For the area of our first place, or our first region, the base is 2, the height is 1. So it's 1/2 2 times 1, which is a total of 1. Area of our second part. This is a 1 by 1, which is half of base times height. So it's half of 1 times 1, which is 1/2. Of our third part, that's just base times height. 2 times 1 is 2. And of our fourth part, we add the bases, 1 plus 2, multiplied by the height. 1 plus 2 is 3. 3 times 1 is 3. And then divide by 2. And so it's 1.5. So the total parts added together give you a total area of 5 square feet. All right. Example 5 is very much like example 4. I'm going to help get you started by showing you what possible shapes that you can combine. Anytime you can make a large rectangle, we want to do that. So I can see a large rectangle right in the middle here. This isn't the only way to do the problem. It is just a way that will work. I could call this part a triangle. I could call this part another triangle, and those are easy to find base and height. Okay, base and height are perpendicular. Base and height perpendicular. This other portion could be a little bit different. Now, I can make this a triangle because I've got base and height again, and I can make this a trapezoid. You want to use as few pieces as possible. As I've done it, there's 1, 2, 3, 4, 5 pieces. Why don't you take a moment or two, add up these total areas, and see what we get. When you're ready, you can continue watching the video, so you'll probably want to pause. Okay, if you use these regions, the area of our first part is 6. 2 by 3 is 6. Area of our second part is 2. This is a base of 4, height of 1. Area of our third part is 1. Area of our fourth part is 1.5. Area of our fifth part is also 1.5. These give you a total of 12 square feet. All right, hopefully this is a little bit better understanding of how to do composite figure area. We will do more of the examples like these in class, so good luck.